Welcome back. Today we are going to talk about topoSet in OpenFOAM. Let's say you are interested in making some topological changes to your mesh. For example, you want to create a hole in this existing mesh, which is like this here. You can also create this hole by creating your geometry in such a way. But there is a feature in OpenFOAM which is called topoSet. There you can create topological sets. For example, this is a annular topology, so where there is a hole. Similarly, you can have two holes in a domain. That is another kind of topology. These kind of topologies can be created in OpenFOAM using topoSetDict. We'll see that how we can create these kind of geometries. This is one domain, this is another domain. This domain has a hole here and there is no hole here. This is the overset mesh part of that. And then there is a background, which is the biggest domain, and that has its own mesh. If we close these two, you'll see that there is nothing, no holes here. And I wanted another domain which has a hole here and one more which is overlapping both the domains. Some portion of it is overlapping both the domains and has a hole in between. We will see that how we can use topoSetDict to set up these kind of simulations, which is sometimes very convenient. So let's get started. So let's start by creating the folders. I have created a directory topoSet. In this folder we will set up the OpenFOAM simulation. We are not going to simulate anything in this particular lecture. We'll just create a domain, and then according to our need we'll create holes in the domain, and we'll see that how we can do it using topoSetDict. I'll create 0, system, and constant. Once we have created these three folders, I'll use VS Code to edit these. Let me open VS Code. This is our VS Code directory. I can create one file here which is called blockMeshDict, and I'll copy the initial format for this. As usual, instead of creating these folders, we'll copy the cavity tutorial. Let me copy that. I have copied everything here. Let's start editing. First of all, I need the scaling to be 1, and let me copy the coordinates for these. Since we are not simulating anything, let me use these coordinates only. This is how you can create a hex block. And for the grading, I'll use little bit higher number of grading so that we can create squares in between as per the need. And then these are the boundaries. Let me run blockMesh here. Now if we open this, we can see that we have block which has all these edges. Now let's create topoSetDict here. For this, we can just copy this and create a file topoSetDict and rename this as topoSetDict. In topoSetDict, you need to pass some actions. These actions, they always take place in the order you write it. Let me first write, you have to write all the actions inside these curly brackets, and then you name. These names can be anything. I'll name this as my set, and then you have to write the type. Type is a cellSet. We'll also see in the code that what are the types that are available, what are the actions that are available, and then what are the sources that are available. We'll choose region to cell, and then you have to pass an inside point, so you can have multiple points to make sure that you select the correct region. I'll choose 0, 0, 0, and once you run this topoSet, so semicolons are missing, UF, you have to make sure that this bracket is in the next line, otherwise you'll get errors. Here you can see that there is a cellSet with the name myset has been created. It found this on processor 0, and then my cell has a size which is same as the mesh. You can check that by running blockMesh again. In the blockMesh, you have a total of 10,000 cells, and when you run the topoSet, it selects everything. So what this particular operation is doing, it is choosing region which it is getting first, and then if inside that region you have this point, it selects all the points which are inside that particular region. If there is another region which is not connected to this first region, then it won't select those cells. This is helpful if you want to select all the points in region 0, and if you want to select all the points in some other region, say region 1 or 2, it won't do the thing for you. So make sure that if you are interested in all the cells in region 0, then use this operation. Then after doing this, we'll first go to the source code of OpenFOAM and look at that this particular version of OpenFOAM is 2412 by OpenCFD. This is not the version which is from OpenFOAM Foundation. You can check that by going to etc and then bash rc, and you will see that this one is from OpenCFD. If you go to source and then in mesh tools, you go to topoSet. Inside topoSet, you will find different sources which are possible. You can have cell source, you can have cell zone, you can have face sources, you can have face zone sources, you can have point sources, and various other. Inside cell source, let's go to region to cell. Here you see that you can only have cellSet as a type. Whenever you are choosing a region to cell, you can only have cellSet as the type, and then you have to type any name. You can have any name, and you can have actions. Let's see what are the types of actions. Actions are given here. Options for actions are, you can have a new. Whatever you create, that will be a new cellSet, and that will be selected from whatever operation you are doing. You can have add. It reads the existing cellSet and then adds it to the cellSet. The source here should be region to cell, but you can have other sources. For example, box to cell. Here you should have a box to cell, and then inside this you should have boxes. In the region to cell, these are the mandatory entries. Inside this you should have an inside point. You can have multiple inside points, but at least one is required. These are other optional entries. You can limit it to a set. You can also limit it to a zone. This will be helpful. We'll see that how. Now, in order to create a box out of it, you can write name as a box. Again, the type is cellSet, and then action is new, and I want to copy cell to cell. I want to copy everything that is in the my set. Then if you go to cell to cell, you will see that you should have a mandatory source. This one is required, and then you can have conditional mandatory entries. You have to have at least one of these. Either you can have sets or zones. We'll go to sets. We'll select a sets, which is my set. It will copy everything which is in my set. We have created two of these. Let's see if this is working fine. We'll again run topoSet. There was some problem. This should be inside bracket. In the source code, it says that the sets should be inside this. Let's do it like this, and then again run. Now you can see that it created a box, then applying the source cell to cell, adding all elements of set, my set, to this. If you have multiple sets, you can combine them into one. Now let's use this to create a box, and then the type is cellSet, and then the action I want is a subset of. Let me go to topoSet source. In the actions, you can have a subset as well. There are other options as well. These are the derived ones. These are the basic ones. You can use these as well. Then my source is box to cell, and then I have to put in the info about the box. I have to put the diagonal entries for the box. My first point is, let me look at the blockMeshDict as well. This goes from 0 to 1 cross 1. I can have from 0.45 to from 0.45, and this one could be 0 to 0.55, 0.55 and 0.1. Let's see if this box is created or not. Again, we have some mistake here. This does not require these two. Now a box has been created which has only 100 cells. And now I want an invert of this. A CFD simulation is outside the box. Therefore, I can take the box, my types remain the same, and the action is invert. Now everything outside this particular box will go to the box. So now you can see it has removed these 100 elements. So inversion of this is all 9900 elements. And now you can also check these by typing foam to VTK and then naming the cell set. Our cell sets are mySet and box. mySet and box. We can visualize this. This is the original one with the edges. Now let's open this, which is VTK, mySet and box. Let me switch off these, and you can see the box is everything except that this particular box that we have selected, and then we inverted, and this one is the entire domain. In order to overwrite this particular cell set, we can use this particular application present in OpenFOAM. This is the application name. Then it is saying that choose box cell set, and in that, when you are creating new surfaces, name that patch as whole and override the existing mesh. Now if you go here, you can check that you have the new mesh as this, and the whole is named as this. This is the whole. Right. Now let's do something more. Now let us assume that you have two domains here. One domain here and another with some other dimension. Let me choose the points which are from 0.2 to 0.3 in x and 0.2 to 0.5 in y. According to this, we'll have these points. I can create another hex with these points, which is 8, 9, 10, 11, 12, 13, 14 and 15, and I can choose a different grading as well. I'll choose say 50 points. Let me choose 40 points, and along z only once, and everything else we need not to touch. Now again let me run blockMesh. Here in the blockMesh you will see that you have two regions that it has created. So let me open ParaView. You can see there are two regions which are inside each other, and there is no distinction as such in terms of number of elements and all. Let's see how we can create a hole inside this particular smaller domain using topoSet. Now let's go back to this. Whenever we are selecting any point, let's say if I select 0.25 and 0.25, this should be inside both the regions. Let's see what mySet is selecting. Let me run topoSet. mySet selected only 10,000 points, but in reality we have 12,000 points. It did not select the newly created 2,000 points. As I said before, that this only selects cells from the region 1, not the other region. Let's see how we can select the cells from other regions. We can copy this. We can rename this as mySet2. Why we are doing this? Because we want to create another set and then we want to invert this. Inverting this will give us all the points in the other region. I'll create another region which is name set2, type cellSet, and action is invert. If I again run this, you'll see that mySet has 10,000. Then when we created mySet2, where we copied everything from mySet, and then we read mySet2 and then inverted it, then we have the other 2000 cells. Now we'll take these 2000 cells and create a box inside that. That is easy. We'll just go here and we'll first copy this to box. We'll copy this command. We'll create box first, which is a box created from my cellSet 2. This command will read the box first and then create a subset out of this. When we invert, we'll get everything except this box. Let's see if this works. We have this my cellSet 2, then we created a box which is a copy from this, and then we read this. It read cellSet box size 2000, and then it created a cellSet of size 325 out of the box which it was choosing, because we set the action to subset. If we choose this to be new, it will create a box by selecting cells in both the regions. The next one is we inverted so that the box will have everything except the box that we have created in the previous action. Let me again open this. First let me convert this box and then my set and my set 2, then open this and all the sets. This one is the original. This one is the bigger domain. You can check the mesh with edges, nothing inside this. Then we have the smaller domain, which is this one, and then we have the domain with the hole, which is this one. You can see the hole, which is a little bit outside the original domain. And then we have this one, which was the original mesh. Now we can again use subset to create the new mesh which will overwrite, and the surface which it will create, it will name it as hole. You can see the new mesh is this, and the hole is this inner patch, just this one. Now let's do something else, which is we want to create 3 domains and then select cells out of it. That is a little bit tricky. Let's see how we can do it. These 3 domains, we want them to be overlapped. I want this to be inside, say from point 1 to point 6 in X, and point 1 to point 6 in Y. And here let it be like this only. Now once we have created these, we can create a hex block. Here one thing that you can do is name these regions as region 1, region 2 and region 3. Once we do this, we can use one more feature of topoSet which will help us to create select cells easily. We can create the blockMesh. See, we have 3 zones: zone 0 with name region 1, zone 1 with name region 2, and zone 2 with the name region 3. You can also see that here in cell zones. Now while selecting this, we can also tell it, you can go to the source code as well and see that you can also tell it that what zone you want this from. If I select zone as region 1, then it will select it from there. Let me change the number of cells so that we know which region is which one. I'll use all the points which are inside all the regions, but I'll just change the regions. Region 2 and region 3. This is my set 2 and this is my set. Let me name this as 2, name this as 3, and we can comment all this off for now. Now let's see if it selects the correct region or not. If we run topoSet, we'll see that in my set it selected 10,000. In my set 2 it selected nothing, and here also it selected nothing. Let's see what was the issue. Here we have to select zone to cell. Remember, there are various options, because this region to cell always selects from only one region, which is the region 0. If we change this to zone to cell, then we'll have respective number of cells, which are 10,000 from the region 1, 2,000 from region 2, and this from region 3. Now we can create the boxes. Let me create boxes from my set 2 and 3. This is from my set 2, which we need as is. This one is box 1, which is cellSet from my set 3. We're going to copy this and then subset it. Box 1, subset this from say 0.35 to 45, from 35 to from 3535 to 4545. And then final step that we need is we want to add these two. We can add everything to box, add, and then source is cell to cell, and then set is, we can also have set as box 1, and then we can invert everything. Name box, and then type cellSet, and then action is invert. We have my set 3 here, then box here. Box, it selected 325 points here, and another box 1 selected 100 points. Total there were 425 points, and eventually this much in box. Again, we can have subset mesh. It will create the final mesh for us. I'm not showing all the VTK files now because I hope you understand it now. Here we have, but somehow we only have one mesh here. Let me just check. Let's first remove everything from constant polymesh. First create the block mesh and check if we have 3 meshes or not. We have one, but I don't see the other one. Maybe the grading is making it to overlap. Let's change this to say 56 and to this the one to 61, and then create this block mesh. So I was correct. We have these 3 regions, and now if I run topoSet and then subset, then we will have these things with holes. So you can see 2 holes, one is here and one is here, which was not there in the previous mesh. These kind of topological changes are required when you don't want to create those geometries. If you want to have these changes within your application and you want to constantly make these changes, it is much easier to do these kind of topological changes. These are also required. For example, we have created these sets, my set 2 and my set 3, and for all these regions you want different properties. So you can use these sets to create different properties. You can have different property to the box as well, and various other things. Therefore, learning that how to use topoSet in OpenFOAM is very important. With this, I hope you have learned something from this particular lecture, and if you like our content, then you can like, share and subscribe to our channel. Thank you.